Alright, this is a review of finding centroid and finding orthocenter and finding, let's see here, centroid, orthocenter, and the circumcenter. I'm going to do two different triangles, all three of these. Let's start with the circumcenter. And let's remember what that is. The circumcenter of a triangle is the center of the circle drawn around the outside of the triangle, hitting all the vertices. So how we find this is by bisecting two sides with a perpendicular. Well, what is a perpendicular? That means it forms a right angle. So I'm looking for this, a right angle. And it needs to be in the middle. So what we're going to do is we're going to choose two sides, one at a time, but we're going to choose a side. We're going to find the midpoint. And then we are going to use the slope of the line to figure out what the perpendicular is. So remember, perpendicular lines have negative reciprocal slopes. So if the slope of the line that I'm bisecting is, say, -5/2, as I read left to right, that's a mistake that's very common, is to go backwards. We read left to right. But if this is the slope of the side I'm bisecting, then this is the slope that I'm going to want to use for the perpendicular. I flip it and switch the sign. And if it were 1/3, I would flip it and change the sign. So let's go ahead and do that. So we're going to find the circumcenter by bisecting two sides. So I'm going to do, first of all, the easy side is going to be this flat side, because its slope is 0, and here's the midpoint. I just get that by counting. 3 on the left, 3 on the right. You could use your midpoint formula if you want. But the perpendicular is going to be then vertical. So it's going straight up and down. So we'll have this. Alright, and we want to make sure that we draw it right through. Okay, now I need to choose another side to go ahead and do that. I'm going to do this side. Because I'm suspecting that my circumcenter is going to be somewhere over here. So finding the midpoint of this is going to be a little bit tricky, but I'm just going to count it out and just kind of see if I can eyeball a middle. And of course, what do you know? I can't. But it's going to be like right about here. So I chose perhaps poorly on this one. I probably should do this other side, but whatever. So right there is the middle. I eyeball it, but I could, using my midpoint formula, actually calculate where that midpoint really is. So I'm using this as my midpoint. It's the middle of these two things. Am I a bonobo? Let's see here. 1, 2. Yes, I am. 1, 2. It should be right here. Here's my midpoint. Yes, that's the middle. Right there. So 1, 2. Yeah, that's the middle. How I got that was I just used my slope and I was counting this. So I have two slopes right here, and I have two slopes right here. So right there's the middle. Okay, so now that I'm not messing that up anymore, let's go ahead and do the slope. So I need the line perpendicular. It needs to form a right angle with this side that I've selected. So I've already counted out my slope once, but I'll do it again. So I start at the left and I count my slope to the right. So it's down. See, slope is change in y over change in x as I read left to right. So down 3, right 1. So it's -3, 1. That's the slope of this line. The perpendicular, then, I flip that and switch the sign. So from this point, I'm going to count up 1, right 3, up 1, right 3. And that should give me plenty of points to go ahead and connect. And where these meet, this right here, that is my circumcenter. Okay, where those two perpendicular lines meet, and they should actually look like they're perpendicular. Alright, I'm going to erase all that, and let's do one more perpendicular. I'm going to delete those segments right there. Don't need them. And let's do another circumcenter, but this time on a different triangle. So let's go to the next triangle. That will be this one. So again, perpendicular bisectors. So I'm going to choose this side, and I'm going to bisect it. That's the middle. So there's my midpoint, just eyeballing it right there. And in your homework, they are meant to be eyeballed, so there should be the one that's fairly obvious. Now I do the slope. I count left to right. Some people would start counting here and then go like up 4, left 1. Not a good idea. Always go left to right. So I'll start up here, or I'll start right here, down 4, right 1. So down 4, right 1. So the slope that I want is the reciprocal of that, which is the negative reciprocal, which is 1/4. Flip it and switch the sign. So this means go up 1, right 4. I always want to go left to right initially. Up 1, right 4. Yes, that does put me off. But now I know which way my line's going to be going. So now it's easy to avoid making the mistake of drawing my line backwards. This is fairly common. Okay, so there is my points. So I'm going to draw this line through there, and hopefully there's no problems. Okay, finding the circumcenter. Notice it doesn't necessarily meet that vertex. The perpendicular bisectors just bisect the sides, and they're perpendicular to the side that we're bisecting. So we do need one more. Let's see here. I'm going to use this side. Let's see it. Count 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 over. Looks like right here. 1, 2, 3, 4. 1, 2, 3, 4. Yep. 1, 2, 3. 1, 2, 3. Yes, that's the middle. Again, I could use the midpoint formula with this point and this point to actually figure out what that really is numerically, but I think that's right there. Alright, so now I need the negative reciprocal slope. So I need the slope of this line. Okay, I'm going to read left to right. So up 1, 2, 3. So up 3. Right 1, 2, 3, 4. Okay, so that's 3/4. So the negative reciprocal is negative 4/3. So from this point, I'm going to go down 4. 1, 2, 3, 4. And right 3. 1, 2, 3. Okay, and that should be sufficient. So I will eyeball this in. Use a ruler. And this should make a perpendicular. It should be 90 degrees right there. That makes this my circumcenter. Alright, so that's circumcenter. The next one, which is very similar in how to find and involves perpendiculars yet again, is orthocenter. So let's do that one next. We'll back up to this previous triangle. So orthocenter, very closely related as far as how we find it. The orthocenter, in order to find it, we're going to use the altitudes. Well, what are those? Well, altitudes are drawn from a vertex perpendicular to the opposite side. So again, I'm using perpendiculars, but this time, instead of starting at the side, I'm going to start at a vertex. So let's say I choose this vertex. Well, then the side opposite, see, I'm going to draw to the side opposite. The side opposite is going to be this side right here. That's the side opposite. Well, what's the slope of this? Well, it's 0. It's flat. So a vertical line going straight down is going to be the altitude. Okay, you could think these as heights of triangles, and essentially. Okay, I'm going to choose one more. So my orthocenter is somewhere on this. I'm going to choose this vertex as my second vertex. Again, I am drawing the perpendicular to the opposite side. So the side opposite of this vertex is this side right here. So I need that side slope. And that side, the same as before, is down 3. See, down 3, right 1. So its negative reciprocal is 1/3. So from this vertex, I'm going to count up 1, right 3. Okay, so that's which way I'm going. So this is actually going to go off my page. So when I reverse it, it's going like way down. So my ortho center is going to be way down off is somewhere down there. Ortho center, way down there somewhere. Alright, hopefully this next triangle actually works out better. Well, let me delete all this stuff. Go away. And get rid of this. Get rid of this. Okay, and we'll go over here. Ortho center. So I choose my vertex. The side opposite of this vertex is this one right here. I need its slope. Its slope is, well, I'll just count left to right. Down, 1, 2. Right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so down 2, right 10. That reduces to negative 1/5, so I really could have counted to that point. So the negative reciprocal is 5 over 1. So that's going to be, go up 5, right 1. Okay, so I'm going over here somewhere. So I'll reverse that. Go down 1, 2, 3, 4, 5, and left 1. So when I reverse it, I need to remember as I go left to right, it should be exactly what the slope is. So from here, if I go up 5, right 1. So reversing it worked out fine. 1, 2, 3, 4, 5. Okay, get a couple points here. And that should be perpendicular to this side because I used this side slope. So I drew it from my vertex down. Okay, I need another altitude, so I'll just go ahead and choose this point. So I'm going to use this line right here. And this line goes down 4, right 1. So down 4, right 1, I'm going to flip that 1/4 and go up 1, right 4, up 1, right 4. And then I connect those. Okay, and that should be perpendicular. See, it's perpendicular to that opposite side, just like that one. So this is my ortho center right there where those two meet. Alright, the last one that we need to do is actually the easiest. So we got through the two complicated ones. Now we need to do the easy one. But the easy one is so easy, like we might get it mixed up with the more difficult ones. So we'll go back. Now we are going to do centroid, and centroid is also the center of gravity if this had some mass to it and was evenly distributed. The centroid we're going to find by doing the medians. Well, a median is not necessarily perpendicular, but it does bisect the opposite side. A median is drawn from a vertex to the midpoint of the opposite side. Okay, so if I choose this vertex right here, this is the opposite side, and this is the midpoint of that opposite side. So I will connect. And the centroid is always going to be inside the shape. It wouldn't make sense for the center of gravity of a triangle anyway to be anywhere else. Let's see here. This, I believe we said, was the center of this. Yep, that is. And this is the vertex. So I choose this vertex. This is the midpoint of the opposite side. I just connect those. Okay, and that makes this my centroid. Now the centroid has a very interesting property where if I knew this length, and let's just make up a length, let's say it was 18. Well, then this short piece here would be 6, sorry. It's a third of the whole length. And then if I double that, I get 12. That's this one's length. And let's just make up a number. Let's say this short piece right here for this one, let's say that was 4. Then this whole length would be double that, 8. And then if I add them together, I get 12. Now those lengths that I suggested there did not necessarily make sense for this triangle. Alright, let's do the next triangle. And again, we are going to do a vertex, and we're going to draw to the midpoint of the opposite side. This is the midpoint of the opposite side right here. So I connect those. Notice it does not necessarily have to be perpendicular. Perpendicular has to do with the orthocenter and the circumcenter. Alright, let's say I choose this as my other vertex. It looks like this right here is my midpoint. Okay, how do I get that? I'm just visually looking at it, inspecting it. I'm looking like this is up 3, this is up 3 more to get to this vertex, so in the middle would be right here. Alright, and then we connect those, and that makes this my centroid. Right here is my centroid. So let's say this whole length right here, let's say that was 9. Then this little piece is a third of that. So divide it by 3, I get 3. This longer piece is double the shorter piece, so 6. Add them up, I get my 9. Let's say this long piece on this one, let's say that was, just for the sake of your argument, let's say that's 7. Okay? Then this piece is half of that, so that's going to be 3.5. And if I add those up, I get 10.5 to be the whole thing. Okay, that is the review of centroid, orthocenter, and circumcenter.